The Earth's climate has changed throughout history. In the last 500,000 years, the planet has experienced several cycles of global warming and cooling events, where ice sheets have subsequently expanded and retreated. During the last ice age, which was about 110 to 20,000 years ago, ice sheets had expanded as far south to cover portions of the northern United States. Towards the end of the last ice age, global temperatures began to rise. Now, as global temperatures change, the Earth's climate can respond and react in different ways, such as changes in sea level or changes in ice sheet growth, or even changes in rainfall distribution, where certain regions could receive more or less rainfall. The Intergovernmental Panel on Climate Change, the IPCC, predicts global temperatures to rise by as much as 4 degrees Celsius by the year 2100. This rise in temperature could cause extreme weather, severe droughts, and rapid sea level rise spanning all across our globe. So to understand how our planet will be affected by future changes in climate, we really need to look at past climate and see how certain regions responded to changing conditions. One way to study past climate is to use material that had grown in the past and that potentially preserved climate conditions from the past, such as rainfall or temperature. And one such record involves using stalagmites. So stalagmites are found in caves, and they're typically made from calcite. If you've ever been inside of a cave, stalagmites are the long, conical-shaped formations that grow from the cave floor. And they're useful for studying past climate because they can grow for thousands to hundreds of thousands of years and can capture thousands of years of climate information. More specifically, we can use stalagmites to understand changes in rainfall.
Alright, so if you're really quiet, you can actually hear water dripping inside of the cave. So this dripping water actually comes from rainwater that falls above the cave. And this rainwater carries with it certain minerals that cause these cave formations to form. The rainwater also has certain molecules in it that are reflective of the rainwater above the cave. So essentially, these cave formations can actually preserve information about the rainwater falling above the cave.
So much like tree rings, stalagmites grow with visible laminations that can be used to interpret or identify their age. And so we can essentially develop records of changes in past climate by using the laminations and analyzing the molecules that were originally from the rainfall and had been preserved in the stalagmite. Therefore, by analyzing the stalagmites, we can identify changes in rainfall through time. Now, my research involves using stalagmites that were collected from Central Texas caves and had grown during the end of the last ice age, and using the stalagmites to identify changes in rainfall over the region. This kind of research is important, particularly in areas that are sensitive to drought, such as Central Texas, which could be affected more heavily by changes in climate and experience less rainfall and more drought-like conditions. On a broader scale, I'm hoping that my research will help understand how future climate warming will affect rainfall movement to drought-prone regions.